Hi, I'm Tom Stahovich. I'm a professor of mechanical engineering, and my background is mechanical engineering and computer science, and for the last probably 7 or 8 years I've been doing education research from sort of an unusual perspective. So let me give you sort of a motivating example. So there was a recent article in Nature, and some researchers glued these little markers to the backs of ants. And then they put cameras above the anthill, and they tracked the movement of the ants for 41 days. And then they did data mining on the video they collected. And they were able to understand how the ant culture worked. They were able to understand the different roles that ants played in the ant society and so on. So if we can use approaches like this to understand how ants work, how come we can't do the same thing with students? And the answer is the IRB won't allow you to do this. Okay, so what have I done? I've developed some technology for monitoring what students do, for instrumenting their learning behaviors. So I use digital pens that are made by Livescribe. So as students do written homework assignments, I collect all their pen strokes with timestamps. So at this point, I have something around 50 or 60 million pen strokes that I've collected from students with timestamps. Students use a special document viewing program that we created to read their course materials. We give them the course materials in an encrypted format so they can read them only with our document viewer. So at the beginning of the course, we give them a tablet with the documents on it for free, and all they have to do is read them. So we collect all this data. You know, as an instructor, I get feedback about what the students are doing in the class, you know, what learning activities they're engaged in, and then we're building automated feedback systems that identify students that are at risk for failure in a course and provide automated coaching for them. This is, for those of you who haven't seen them, what a Livescribe pen looks like. There is an infrared camera in the tip just behind the ink cartridge. The paper has a special dot pattern on it, and as students write, the camera images the dot pattern and it decodes the location of the pen on the paper. So the pen knows precisely within 1/10 of a millimeter where the pen touches down on the paper, and I collect this data with millisecond time resolution. So I have literally 60 million timestamp pen strokes like this. And so here's what the ink looks like. This is somebody solving a problem. We've added, our rendering algorithms have rendered the ink. And the color coding here, the red, shows what was written last. The dark blue at the top was what was written first. And it's interesting that there's some red up here at the top. So let me show you a video of a student. This isn't a real student because again, the IRB. But this is typical of what we see. And this student really did, this is one of my grad students, he really did this. So he's solving the problem. You can see, sorry about the resolution on the screen, but starts red, blue rather, becomes red. The student thinks he's done, and he's looking at his work, and he realizes he made a mistake. He crossed it out. He went back and changed the direction of the arrow. He flipped a bunch of minus signs, and now he has a new answer. So my algorithms have access to not only the final ink on the page, but the order in which it was written on the page. So I get to see the students' process in solving problems. And so there's a lot of things that we can do with that. But the title of the talk, so I'll start with this first, is Homework and Achievement. So the question is, in STEM courses, we all assign homework. Is it useful? Do students actually benefit from doing homework? And people have looked at this question for a long time. So the earliest study that we found was from the 1920s. And there was a negative correlation between study time and first semester GPA. Okay? In 1985, another study found that there was very little correlation. So we went from a negative correlation to no correlation, and then a more recent study basically said you can't really tell what students are doing from what they tell you about what they're doing. So if you want to know if students are actually doing homework or if they're benefiting from it, you actually have to watch them do it. So I teach an introductory statics class, which typically has 150 students. I can't watch all of them, or at least I couldn't. Now I can. I use these pens. So I know exactly what they do. I know if on a Saturday night at 2 in the morning they're writing on their homework, and the answer is they're not. So the course is Statics ME10. It's a required sophomore level engineering course. It's a pretty challenging course. For majors, they have to get at least a C in the course to move on in the curriculum. So it is a difficult course. We use data from 3 different cohorts of students. 328 total students were in the study. And we looked at homework, quizzes, exams, everything they wrote in the class, with excluding lecture notes. And this data set was 6.6 million pen strokes. And we also did an end-of-course survey. We asked students, how much time did you spend doing homework? And so what we found was that, in fact, there was a correlation between students' self-reported homework time and course achievement. Unfortunately, it was negative and statistically significant. Okay, so the students who self-reported doing the most homework actually did the worst in the course. But we used our digital pens to measure how much time they actually spent writing on their homework. And we found a very strong, statistically significant correlation between time actually doing homework and course grades. So students who spent the most time on homework did the best. Students who thought they spent the most time on the homework did the worst. Okay. We looked at how much homework they spent doing in the wee hours between, I think we said midnight and 4 a.m. There was a slight negative correlation between doing homework then and course grade, but it wasn't significant. Here's the one that was interesting. We have pen strokes with timestamps to millisecond resolution. So we looked at how much of their writing was done within 24 hours of the due date. The greater the fraction of homework within 24 hours of the due date, the poorer they do in the class. Okay, so we did find a correlation between homework and achievement, but we also found that the nature of that effort matters. Doing it at the last minute is not a useful strategy. We also found that if students broke their homework up into multiple sessions during the week, they did better. So there was a positive correlation between the number of homework sessions and course achievement. Sure.
Do students know that every stroke is being monitored?
Yes. Yes. Yeah.
In other words, they could think, I just want you to think I'm spending a lot more time.
They could, but they don't. And then we have other measures. The number of pen strokes. So not just the amount of time they spent on homework, but how many times did they actually make a stroke on the page? That is a very strong positive correlation, as is the total ink that they wrote, measured in inches along the page. Okay, so what we found is it's not just time on homework, but effortful engagement. There's been a lot of research in the past looking at these things, but all this research has relied on self-reports and surveys. So we've finally gotten objective measures. Okay, here's a relationship between students' self-reported homework time and actual homework time. 95% of students over-reported the amount of time they spent on homework. Okay, so, all right. I only have 5 minutes, so I'll be quick. Okay, so the other question is we all assign textbooks in our classes. The real question is, do students actually read them? And so how much time in a 10-week quarter do you think students would spend reading an engineering textbook? How much per week? 6 hours a week? Okay.
10 minutes.
10 minutes? Okay, we've got 6 hours, 10 minutes. Anything in between? 2 hours. You're right, it's 2 hours over the 10-week quarter. Over the 10-week quarter.
2 hours per week?
Over the 10-week quarter. It's 20 minutes per week. This is the textbook. This is the 8th edition. I used the 1st edition when I was an undergraduate. It hasn't changed except for the price. And we did all of the ink collections, so we have that data as well. This is our document viewer. Students can take notes on it. They can bookmark pages, and we get page viewing data. And we found that students spent 22 hours over the 10-week quarter looking at the assigned homework questions at the end of the chapter. They spent 3 hours and 30 minutes over the entire 10-week quarter actually reading the explanatory text in the chapters. They spent an hour looking at the answers at the back of the book. So they spent 3 hours reading the text and an hour looking at the answers at the back of the book. So what this says is that students use the textbook only as a means of practicing problems. They don't rely on the textbook to try to understand conceptual material. So, you know, if we were going to give the ideal textbook from the student's perspective, it would just be the homework questions and the answers. All right, yes?
With that said, do you supply PowerPoints of all your lectures?
I do, and they didn't read those either.
Oh, they didn't. Okay, so I was going to say.
Yes?
So you know that they're logged on reading. How do you know if they're actually sitting reading and they haven't gone to the kitchen to get something to eat?
Because the screen blanks after a few minutes.
Oh, it doesn't.
Yes. Yeah, we made that happen. We made the documents encrypted so they couldn't be read with other document viewers. But the fact that this was basically 2.2 hours per week reading the assigned homework questions. So they were using the text to do homework because looking at there are 8 questions and looking at them for 2 hours is about right. Yes?
Do you have other incentives like points offered for reading quizzes for before they come to see you in class?
Well, so this first part of this project was just to measure what students do. The second part was to create interventions to see if they changed behavior and if the changes in behavior led to better outcomes. So that's work we're doing right now. Yes?
Just quick question, was the homework graded?
Yes. Yes, the homework was great. Yes. Okay. So, and as a pie chart, this is the same data. Almost all the reading time was spent reading homework questions. Okay, so just another little snippet of what we're doing. We've recently started looking at lecture notes. So is it useful to take lecture notes in a STEM course? So again, students are writing with these pens. We have millisecond timestamps. And so we looked simply at the number of lectures for which students showed up and wrote something. And we found a strong, statistically significant correlation between showing up to lecture and doing well in the course. We found a strong negative correlation between crossing out stuff in your notes. So students who were making mistakes while recording their notes tended to do poor. But this is the interesting one. This is a profile of a student's writing over the lecture. So this is, we break the lecture down into 15-second slices, and we look at how many inches of ink they wrote. And we compare the student's profile to the class average profile. And the greater the deviation between a particular student and the class average, the poorer the student does. So students who are off pace, who are either writing too much because they don't know what's important, or they're not paying attention and not writing anything, those students tend to do poorly. So we can actually get a reasonable indicator of achievement just from the way they take notes. It turns out doodling had no correlation with grade. Okay, and so using several of these features that we compute from their notes, we get a fairly strong correlation between note-taking behavior and course grade. So this explains half of the variance in their final course grade. So some of the conclusions here is that, we have demonstrated the amount of time that they spent on their work does correlate with achievement, but it's more correctly the effortful engagement measured by how much writing they actually do that gives the best correlation. The quality of time they spend on their homework matters, so not doing it at the last minute, breaking it down into lots of different sessions is good. Students severely overestimate their effort. They don't read at all. And they leave homework to the last minute, which is a bad idea. And if I have like 2 more minutes, I'll show you what I'm heading towards next. So we're building automated coaching systems, early warning systems, and we're doing automated grading of homework. And so I too just got an IU's grant 3 weeks ago to continue this. And that's the automated coaching thing. So I'll talk about the other two. So we've used some standard concept inventories, the physics concept inventory, the statics concept inventory, and the physics concept inventory, the statics concept inventory, which we did the first 2 years, had no predictive power. The physics concept inventory had a little. We used homework and quiz scores from the first few weeks of the course. They were somewhat predictive of grade. And then we look at what we call IF, ink features, just how much writing and when do they write on their homework. In 3 weeks into the 10-week quarter, just how they wrote their homework was far more predictive. It explained up to 60% of the variance in final course grade. Far more predictive than how they did on the homework and quizzes, their actual grades, and what they did on the concept inventory. And if we put them all together, we can make really good 3-week predictions about what they're going to do at the end of the quarter. So we're doing some work on automated grading. Here's an exam problem, and I won't go into the details of this, but this is a statics problem. The students had to calculate the moment here that was needed to hold that weight up. And we built an algorithm that looks at the spatial and temporal organization of the students writing on the solution. So how did they put the ink down on the page? Did they start at the top and go to the bottom? Did they keep going back up and changing things? Did they do the diagrams first and then the equations? And our algorithm predicted these grades on the left, and human graders did the grades on the right. And just looking at the spatial and temporal organization of the work, we can explain most of the grade. So if you've ever had that intuition that you could look at a student's solution and tell if they got it right without grading it, we can. And it turns out that we don't even look at the final answer. We just look at how did they solve it. So one of the things that we do here is we divide their writing process up into like 30-second slices. And we say, are they drawing diagrams? Are they writing equations? Are they working on some other problem, digression? Are they just doing nothing? And so we get this little DNA sequence. And we can compute properties of it, like its entropy and complexity. So we represent this as a string of characters. So working on a diagram might be a D, doing nothing might be a 0. And we get this string of characters, and we compress it like you'd compress a file with a zip program. The smaller we can compress the string, the simpler the student's pattern of work is. And that tends to correlate with better performance. So we can actually analyze how they organize their tasks in time as a very good predictive measure of how well they're going to do on that material. So let me wrap up, because I think I've exceeded my 15 minutes by 5 minutes. But using the pens and the tablets, we're now able to apply sort of big data type approaches to understanding student learning in STEM courses. So we're really treating this like an experimental science, and we're using some innovative ways to instrument those learning behaviors. We've discovered from this first phases of the research that students severely lack engagement in what they do. They don't read, they do homework at the last minute. We're now working on a grant to try to build automated tools that try to keep students engaged and get them to do the things that they should be doing. We can predict academic achievement fairly accurately and fairly early on in the course just by looking at patterns of homework effort. And we can also make fairly good estimates of the correctness of a student's work just by looking at how it's organized in space and in time. So this work has been funded by 2 NSF grants and now a third. My collaborators, Rich Mayer at UC Santa Barbara, and I have a big team of grad students here at UCR that have been helping me on this. So thank you. Yes?
Yeah, I was curious, the strong response to pen strokes in the classroom makes sense given that they don't read. So, yes. I mean, what's happening in the classroom really is critical. I'm curious if you have any sense, if they did read, if they have to be as attentive in class.
That's a good question. So we did a study this last year where we actually gave students a weekly progress report that says, you spent 4 minutes reading the chapter text this week. We'd like you to try to read longer for next week. And one of the problems is that they didn't read those progress reports. Yes.
What was the cost per student for the Smart Pen and the thing they had to take home with them?
The Smartpens are about $100. And then we developed all the software. And because of this being a research project, we paid for the licenses for the textbook, which cost us about $35 a student. Yes?
So many of the students are taking notes on their computers, and I was wondering if there's going to be any attempt to see whether that differs from writing, taking notes during class.
So I found that in my courses, students, because there's so many diagrams and equations, students tend not to use laptops. But if they are typing, if we give them, a note-taking tool, it actually is an easier way to get the data. We had to go through a lot of effort to get handwriting. So anything that students do with a keyboard actually makes our job easier. But we haven't looked at that because that really hasn't been an issue with our student population. Yes?
Yeah, I was intrigued at the connection between, reading homework. They're spending all this time reading homework, and then a lot of them are still doing their homework at the last minute.
Yes.
And I'm wondering, for the students that are waiting to the last minute, is it that they read the homework earlier and they get scared off? Do they repeatedly visit the homework pages and then finally do it at the last minute?
So that is a good question, and we're doing that analysis right now because we have the timestamp page views of the textbook and we have the timestamp pen strokes, and so we're putting the two data streams together to see what is the relationship between reading and writing. But we don't know yet. Yes. Yes.
Susan Strom, UC Santa Cruz. Can you actually tell whether students are working together? By whether their timestamps are identical and they're making the same forays into odd places and then backing off?
We can, but we don't look for that because if we do, we will never get students to participate in the research. But we anonymize all the data, and one of my graduate students found some kind of an anomaly, and he was looking into the data. And so we played the three videos of three students. Student A wrote something, student B wrote it, student C wrote it, student A wrote something, B and C, and so on. So we could very easily detect collaboration, but we don't look for it. Yes?
It was very interesting to hear about the feedback to the students, that these tools can be used for that, not just for research. But then you went ahead and you said that you've tried very simple feedback and they didn't work because they never read it. So what are your thoughts about how this feedback would actually work?
Okay, so I may have overstated that they didn't read it. The students did read some of the feedback. But what we're doing is we're actually now building a system where for them to get their next homework assignment, they have to pass through something that gives them their feedback. So we're making it so that there's no way they can avoid seeing it. Yes?
It seems like most of the habits that you're documenting are ones that the students come to the class with.
Yes.
And so I'm wondering, do you see individual students whose habits change over the course of the quarter? Or do they come in with what they have and leave with the same thing?
Yeah, so we haven't really seen changes in behavior yet. I'd like to track these students over subsequent years, but they come in with habits, and one of the things I've done is I've asked our students, to get into engineering, they had to have A's in high school. So I typically ask my students, how many of them got through high school without doing homework? And the majority of students raise their hand. So they learn that they can be successful without doing anything. And so part of the challenge here is breaking those habits. Yes?
So I'm curious, have you ever considered having the students use the pens while they're taking the test and then using it as a tool to maybe do like individualized test preparation and test coaching with them? Like maybe one student, every time they cross something out, they had the right answer, but they're crossing it out. Or another student spending way too much time on the first problem and then they don't get to the rest. And maybe use it as an informative tool on the test?
That's actually a good question. We hadn't thought of that. We have all the test data. So we could analyze that. We haven't. So yeah, we literally have tons of data, and we haven't been able to do all the things we want. But that's actually a very good idea.
One more question.
Okay.
Okay, Kyle, I was wondering what did the students in your class think about the class and you as a teacher after this experience?
Well, most of the students liked that I was trying to figure out how to improve teaching and learning in the class. There were a few, a very small percentage of students, a handful, that thought that this was very tedious and too much effort on their part. But generally the students, didn't object to it. And, participation in the research is voluntary.
Thank you so much.
Thanks.
Just need your mic.